afternoon, everyone. Good afternoon, Doc. I'm Cypress Pitangan, and I'll be your reporter today. So the topic that I'll be going to discuss is about Spearman rank correlation coefficient up to the line graph in Table 8.6. Now, let us define the Spearman rank correlation coefficient, or what we call the Spearman law. So Spearman rank correlation coefficient, or Spearman law, is used both descriptive research and experimental research, similar to person-product moment correlation coefficient. So Spearman law is another measure of correlation which is used to measure the relationship of paired ranks assigned to individual scores of two variables. So this is a correlation which estimates the degree of two association of two sets of variables in an ordinary scale, or the first, second, third, and so on, so that the subjects or the data under study are ranked in two ordered series. So Spearman law is commonly used to measure the disarray of summation of d cubed, where a coefficient of rank correlation has value of +1, where the paired ranks are in similar or in a value of when paired remains are in opposite order. So in overall, Spearman's rank correlation coefficient is a technique which can be used to summarize the strength and direction of both negative and positive of a relationship between two variables. Spearman rank correlation coefficient, or RS, is the non-parametric version of the Spearman correlation coefficient. So this is the formula of Spearman law. RS is equals to 1 minus 6 summation of d squared over n cubed minus n. Where RS is the Spearman law, the summation of d squared is equals to sum of the squared difference between ranks, and the n is the number of cases. So to apply formula, let us know what are the steps in this. So step 1, rank the values from highest to lowest in the first set of variable, and the highest value is ranked first, second, third, and so on. The step 2 is rank the second set of variable in the same manner in step 1. In step 3, find the difference in ranks for every pair of ranks. So in step 4, multiply each difference by itself to get the d squared.
The summation of d squared.
And the step 6, compute Spearman law applying the formula. So as an example, I prepared a data here. Let's try to find out if physical activity has any relation to blood pressure. So in column A, we have the list of names of different men. In column B, represent the number of minutes that the man at the same age spend daily in gym. And in column C, we have their systolic blood pressure. So now, let us try to solve the example of the given data of physical activity and blood pressure by applying the steps. So the first step is rank the value from highest to lowest in the first set of variables. So our first set variables for our example or our given data is the physical activity, and then the highest value is ranked first, second, third, and so on. So the first step that we are going to do is to rank the number of minutes of physical activity. So in our physical activity, we have the number of minutes of 60, 55, 25, 50, 40, 45, 35, 10, 30, and 20. So now, let's do the ranking. So the first in the rank is 60, the second is 55, the third is 50, the fourth is 45, the fifth is 40, the sixth is 35, the seventh is 30, the eighth is 25, the ninth is 20, and the 10 is 10. So that is the number of minutes of our physical activity. So now let's proceed to our step 2. So our step 2 is rank the second set of variables in the same manner as step 1 do. So our second set of variables in our given data is the blood pressure. So in blood pressure, we have the numbers of 120, 125, 130, 115, 140, 135, 145, 150, 155, and 110. Now, let's do the ranking. So, the first in the rank is 155, the second is 150, the third is 145, the fourth is 140, the fifth is 135, the sixth is 130, the seventh is 125, the eighth is 120, and the 9 is 115, and the last one is 110. So that is the ranking of the blood pressure. Let us proceed to our step 3. So our step 3 is find the difference in ranks for every pair of rank. Now, we will be looking for the value of D. So the question is, how do we get the value of D? So by getting the value of D, we are going to apply the step 3. So our step 3 is find the difference in ranks for every pair of ranks. So we are going to find the difference of the ranking of physical activity and blood pressure. So 1 minus 8 is equals to 7. So that is the value of our D. So 2 minus 7 is equals to negative 5. 8 minus 6 is equals to 2. 3 minus 9 is equals to negative 6. 5 minus 4 equals 1. 4 minus 5 is equals to negative 1. 6 minus 3 is equals to 3. 10 minus 2 is equals to 8. 7 minus 1 is equals to 6. And 9 minus 10 is equals to negative 1. So, now, how to get the value of D squared? In getting the value of D squared, we are going to apply the step 4. So, our step 4 is multiply each difference by itself to get this D squared. We are going to multiply each difference by itself to get the D squared. So 7 times 7 is equals to 49. Negative 5 times negative 5 is equals to 25. So 2 times 2 is equals to 4. Negative 6 times negative 6 equals to 36. 1 times 1 is equals to 1. Negative 1 times negative 1 is equals to 1. 3 times 3 is equals to 9. 8 times 8 equals to 64. 6 times 6 equals to 36. And negative 1 times negative 1 is equals to positive 1. So that is our D squared, or that is we are going to get the D squared. So the next thing that we are going to do is we are going to apply the step 5, which is sum the squared difference to find the summation of D squared. So what we are going to do, we are going to add all the numbers under in D squared. So what are those numbers? So 49 plus 25 plus 4 plus 36 plus 1 plus 1 plus 9 plus 64 plus 36 plus 1 is equals to 226. So our summation of this squared is 226, or sum of the difference between the ranks. So this is the ranking of our given data, which are the physical activity and blood pressure. So this is the final rank of physical activity, and this is the final rank of our blood pressure.
So this is the final output of our data.
Let's proceed to our step 6, which is compute Spearman law by applying the formula. So this is the formula of Spearman law. RS, or our Spearman law, is equals to 1 minus 6 multiplied by the summation of d squared over n cubed minus n. So now let's substitute the formula. So let's copy the 1 minus. So what is our summation of d squared? So our summation of d squared is 226. So 6 multiplied by 226 over n cubed, which is 10 cubed, minus our number of cases, which is 10. Next is 1 minus, let's multiply 6 to 226. So 6 times 226 is equals to 1,356 over what is the equivalent of 10 cubed. So 10 cubed is equivalent to 1,000 minus our number of cases, which is 10. Now, so 1 minus 1,356 divided by 1,000 minus 10 is equals to 90, or 990. Next is, let's copy the 1 minus 1,356 divided by 990 is equals to 1.369696. So now let's subtract 1 minus 1.369696 is equals to 0.37. So our Spearman law is 0.37. So this is our Spearman law.
So our Spearman law is 0.37, which means moderate relationship correlation between physical activity and blood pressure. So this is the description of our result.
And a horizontal line. In our horizontal line, it is our x-axis, and in vertical line, it is our y-axis. So in y-axis, we have the numbers of 155, 150, 145, 140, 135, 130, 125, 120, 115, and 110. So in our x-axis, we have the numbers of 10, 20, 25, 30, 35, 40, 45, 50, 55, 60. So in our y-axis, we have our blood pressure. And in our x-axis, we have our physical activity. So we are going to put a dot based on our given data of physical activity and blood pressure. So this is our data of physical activity and blood pressure. So the first in the line is we have 60 and 120. 60 and 120. The second line, we have 55 and 125. 55 and 125. The third in the line is 25 and 130. So 25 and 130. Next is 50 and 115. So 50 and 115. Next is 40 and 140. So 40 and 140. Next is 45 and 135. So 45 and 135. Next is 35 and 145. 35 and 145. Next is 10 and 150. 10 and 150. Next is 30 and 155. 30 and 155. And the last one is 20 and 110. 20 and 110. So the next is we are going to connect all the dots. So from here to here, we are going to connect all the dots. So that is the final output, or that is our line graph in our given data of blood pressure and physical activity.